Welcome back to Daily AI News at Let's Data Science. It's 2026 0405. Today, we're diving into some pivotal developments from the future of machine intelligence to major product launches. Let's get to it. We begin with a dramatic escalation at the intersection of AI, national security, and geopolitics. The United States government has blacklisted Anthropic, designating the company a national security supply chain risk after it declined to allow the U.S. military to use its Claude chatbot for surveillance or autonomous weapons applications. According to reporting published today, Anthropic's refusal to provide military access to Claude triggered the designation. A U.S. judge has temporarily blocked the blacklisting, and Anthropic has filed a second lawsuit challenging the action. The implications here are profound. This is not a routine procurement dispute. It signals that foundation model providers may face direct federal retaliation if they resist defense integration. Anthropic CEO Dario Amodei is now at the center of a geopolitical tug of war. Britain is reportedly courting Anthropic with expansion incentives and dual listing proposals ahead of Amodei's late May visit. That means we're seeing AI firms treated less like startups and more like strategic national assets. Market access, supply chain classification, and regulatory posture are becoming tools of statecraft. This move also reframes the broader debate around AI governance. If refusing military use can trigger a national security designation, every frontier model developer, OpenAI, Google DeepMind, xAI, must now reassess their exposure. The line between commercial AI infrastructure and defense capability is dissolving in real time. And that blurring is not theoretical. It's operational. Project Maven, the Pentagon's AI targeting initiative launched in 2017, is now reportedly central to U.S. strikes against Iran. According to new reporting, Project Maven has evolved into an AI-assisted targeting and battlefield management system that fuses sensor and intelligence feeds and uses large language model interfaces, currently Anthropic's Claude, to accelerate the kill chain. Palantir now serves as the primary contractor for Project Maven. The Center for Strategic and International Studies, or CSIS, cites strike rates of 300 to 500 targets per day. Let's pause on that number. We're not talking about experimental deployments. We're talking about AI systems operating at operational tempo, directly influencing detection to strike decisions. The contractor ecosystem is also shifting. While Palantir leads, companies including Anthropic, Google, OpenAI, and xAI factor into model sourcing. That makes the U.S. blacklisting of Anthropic even more consequential. If Claude is currently integrated into military workflows, any restriction creates immediate operational friction. Meanwhile, geopolitical risk is expanding beyond U.S. policy. On March 31st, Iran's Islamic Revolutionary Guard Corps threatened strikes against 18 mostly U.S. technology companies, explicitly naming Microsoft, Google, NVIDIA, and Amazon. The argument presented is stark. When AI, communications, and IT infrastructure materially contribute to military action, private technology firms become legitimate targets under international humanitarian law. Whether or not that interpretation holds legally, the strategic message is clear. Cloud providers, chipmakers, and AI model labs are no longer peripheral actors. They are embedded in defense logistics, targeting, and intelligence. For practitioners building AI systems in enterprise or research settings, this raises urgent questions about supply chain resilience, infrastructure security, and geopolitical exposure. Now let's shift from geopolitics to the physical limits of computation. At GTC this spring, NVIDIA announced plans to adopt photonic interconnects to assemble systems with more than 1,000 GPUs by mid to late 2028. The company unveiled multi-rack designs named Vera Rubin NVL576 and Rosa Feynman NVL1152. These are not incremental upgrades. They represent a strategic pivot away from copper interconnects toward optical scale-up. NVIDIA has invested billions in optics and interconnect suppliers including Marvell, Coherent, and Lumentum. The goal is to deploy co-packaged optics for NVLink fabrics, reducing pluggable power consumption and enabling larger, lower latency clusters. This matters because copper is hitting physical and thermal limits. As GPU clusters scale, interconnect bandwidth and power efficiency become the bottleneck. By integrating photonics directly into NVLink fabrics, NVIDIA is attempting to extend the scaling curve for high-performance computing and large language model training. If NVIDIA succeeds, clusters exceeding 1,000 tightly coupled GPUs become not just possible, but commercially deployable. That changes the economics of frontier model training and could reinforce NVIDIA's dominance in AI infrastructure. It also signals that the next frontier in AI performance may be optical, not just algorithmic. Speaking of algorithmic efficiency, DeepMind's retro architecture is back in focus today with a detailed breakdown of how retrieval augmented models can dramatically reduce parameter counts without sacrificing performance. Retro pairs a 7.5 billion parameter decoder with a 2 trillion token key value database and BERT-based sentence embeddings to retrieve relevant text chunks during generation. The result? Performance parity with GPT-3 DaVinci, the 185 billion parameter model, while using a fraction of the parameters. The key insight is that factual knowledge can be decoupled from model weights. Instead of memorizing the world inside billions of parameters, Retro retrieves relevant context on demand. That reduces training cost and enables smaller, more deployable models to compete with massive, dense architectures. For practitioners, this is not just a research curiosity. It points to a future where retrieval infrastructure, embedding quality, and database design become as important as raw parameter count. In an era of constrained compute budgets and growing scrutiny over training costs, architectures like Retro offer a credible path to efficiency. Now, for a few other key updates in our lightning round. Meta has paused all work with data contracting startup Mercor following a major security breach. The breach was linked to a supply chain compromise of LiteLM attributed to Team PCP and claimed by Lapsus Dollars. Mercor, which supplies contractors to OpenAI and Anthropic and was valued at $10 billion in October 2025, has launched a third-party forensic probe. This incident underscores systemic risk in training data pipelines and highlights the need for stronger contractor vetting and supply chain controls. The Washington Post reports that private Chinese companies are trading AI-enhanced datasets, tracking U.S. troop movements and armaments. These firms reportedly combine open-source intelligence with commercial satellite imagery, including data from China's Jilin satellite constellation. American Enterprise Institute researcher Ryan Fedosiuk notes the increasing commercialization of geospatial intelligence. For AI teams working with satellite or OSINT data, operational security and data provenance are becoming critical considerations. In industry practice, Zalando has detailed how it deployed large language models to analyze thousands of archived postmortems across data stores, including Postgres, DynamoDB, Elasticache, S3, and Elasticsearch. The company built a multi-stage LLM pipeline specifically to reduce hallucination and context loss, enabling automated pattern detection and thematic clustering for site reliability engineering. This is a concrete example of LLMs delivering repeatable SRE insights and directly informing infrastructure investment decisions. On the research and policy front, Yale astrophysicist Priyamvada Natarajan, winner of the 2025 Danny Heinemann Prize, warned during a Bengaluru visit that shrinking U.S. federal science funding and the corporate consolidation of AI research threaten academic capacity and international student flows. She argues that AI is catalyzing a fundamental shift in scientific method and calls for universities to reclaim AI for science through physics-guided machine learning and university-led computation. And finally, for hands-on practitioners, a detailed tutorial published today walks through Pandas techniques for constructing per-user daily time series with gap filling. By re-indexing with a user date multi-index, zero-filling missing dates, and shifting cumulative and rolling aggregates, practitioners can compute leakage-free features such as lifetime logins, logins yesterday, days since last login, and rolling 7, 14, and 21-day login counts. It's a practical blueprint for robust next-day prediction modeling. Taken together, today's stories paint a clear picture. AI is no longer confined to research labs or product launches. It is embedded in military targeting systems like Project Maven, reshaping geopolitical alliances around companies like Anthropic, driving hardware innovation through NVIDIA's photonic NVLink strategy, and redefining model efficiency through architectures like Retro. The stakes, technical, economic, and strategic, are escalating. And that's your AI briefing for today. The landscape is moving faster than ever, and we'll be here to track it with you. For more insights, visit us at letsdatascience.com. Thanks for tuning in. Stay curious, and we'll be back tomorrow with the latest in AI.